Hi there, thanks for clicking on and watching. Welcome to this video. Hopefully you've done so because you are sitting Maths Edexcel A-Level this summer. Paper 2 is on the 14th of June, so starting to look at putting some questions together on the topics. Here's the list from the exam board, but again they have said that this is just the list for the main focus, but parts of questions may involve other areas of the syllabus. So in this video I'm just going to look at a couple of topics. I have made videos which cover all the topics in 2 parts, so do check them out if you want to look at other areas. Okay, let's get started. I hope you find the content of this video useful and helpful and your revision is going well. Do give it a like and subscribe and check out my other videos too. So this first question is a differential equation question. We've got a bacterial culture which has area P. They're using the letter P to describe the area, and at time T after the culture was placed onto the dish, a scientist is stating that the rate of increase of that area P of the culture is being modelled as being proportional to the actual area, which is P. So as soon as you see that word rate, you know you're going to have a differential equation, because if things are changing with respect to time, we need to write dp by dt. So what is changing? The area which we are using the letter P to describe. So dp by dt is proportional, so that's the proportional sign, to the actual area which is P. Now, how do we get rid of the proportional sign? When things are in proportion, as one increases, the other increases, and there's a constant of proportionality. So we just lose that proportionality sign and say equals Kp, where K is a constant and it's the constant of proportionality. Now we've got a differential equation and we need to separate the variables and integrate. So the dp by dt is not a fraction, but it can operate like a fraction as long as you integrate both sides. So the p is going to come down, the dt is going to go up, and we're going to get the integral of 1 over p dp is equal to the integral of k dt. Now remember, k is just a constant. So p being a variable, how do we integrate 1 over p? It's the ln of p is equal to kt plus c. Now there should be a constant of integration on both sides, but we just lump it all onto one side. So how we're going to get to this equation, we're going to then raise each side to the power of e, and then that will just give us p on that side is equal to e to the kt plus c. Now what we do now is that e to the kt and then times e to the c would cause us to add those indices, which was what we've got here, and then we can just say that a is equal to that e to the c, because it's just going to be a constant. So p is equal to our a e to the kt. So that's part A for 4 marks. The scientist measures the values of p at regular intervals during the 24 hours of when the culture was placed into the dish. She plots a graph of ln of p against t. So you could sort of go back to this equation, but let's stick with this one and do the ln of p. Taking ln's to one side, we'll have to take ln to the other side. And then we can use the log law that we have got a times here. So this is ln of p is equal to the ln of a plus the ln of e to the kt. And then this will be the inverse of each other. So it'll be ln of p is equal to the ln of a plus e to the, not plus e to the kt, just plus kt, which is essentially what we had here, but the constant of integration is actually the ln of the a. Now we're told that when she plots this, it is a straight line. So we can see this is of the form y equals mx plus c. You can see that the gradient is going to be the k, and the ln of a is going to be the y-axis intercept because the t is the variable and the p is the variable. So it's telling us that the gradient is 0.4, so that is just our k. So we can just say that k is equal to 0.14. And then it's telling us that the vertical intercept, which means it's the intercept with the y-axis, is 3.95. So that's telling us that ln of a is equal to 3.95. Now ln means log to base e. So if we just remember that when you have a log, the answer to the log is the power. E to that power is equal to a. So a is equal to e to the 3.95, and if you do that it comes out to be 51.935, which it's asking us to two significant figures is 52. So altogether we've got that P is equal to 52 e to the 0.14 t. So when you have differential equation and you get this set up, you always need to find these constants a and k, and we need, bits of information to feed in to try and find them. Right, on to part C, we're being asked to hence show that the model can be written like this. And so far we have got P is equal to 52 e to the 0.14 t. So we need to be getting rid of that e and replacing it with some constant b. So we can rewrite this as 52 e to the 0.14 all to the t, because the rules of indices would mean you'd multiply them together, which would just get back to here. So we can find what e to the 0.14 is, because that's just going to be a constant, and it is 1.15. So e to the 0.14 is 1.15. So we're being asked to find what b is to three significant figures. B is 1.15. Part D, with reference to the model, interpret the constant a. So a is this number on the front, and whenever you're looking at that number on the front, just think about when t is equal to 0, so that's initially when you've just put the culture into the dish. P will equal 52 times anything to the 0 is going to be 1, so that's 52. So the constant a is the initial area at t is equal to 0. Now part 2, we've got to interpret the constant b. Well, b is this thing here, the 1.15. So what's going on here is, if you think back to when you did compound interest, say I invested £5,000 at 3% for 2 years, you do 5,000 times 1.03 to the 2. So this is exactly what we've got going on here, 52 times 1.15 to the t. The 0.15 there is the percentage increase every t, and t is being measured in hours. So the b is the rate of increase in area, and it's telling us the increase is 15% every hour. Okay, part E, state the long-term limitation. It's limited, the model predicts that the area will continue to increase, but the area is restricted by the size of the dish. This is another partial fractions question and differential equations. They are listed on one line in the advanced information, so definitely a question and area to focus on. So we've got 1 over p into 11 minus 2p, and being asked to express it as partial fractions for part A. So that's equivalent to a over p plus b over 11 minus 2p, because we've got two linear factors. Then we go clear of fractions by multiplying throughout by this denominator. So we'll have 1 is equal to a into 11 minus 2p plus bp. So each of the constants on the top just get the denominator that they've not got. And then we choose values to make each of these terms 0 in turn. So we do the easy one first. If I let p equal 0, I've got no p on the left, so I'll just have 1 is equal to, when p is 0, I'll have 11a, so that will tell us that a is equal to 1/11. And then if we let p equal what will make this bracket 0 will be when p is 11 over 2, so 5.5. So we'll have still 1 on the left is equal to 11 over 2 b, which will tell us that b is equal to 2/11. So writing that then back in, you can write here that we've found that a was 1/11, so it's going to be 1 over 11 over p, but that just looks a bit messy. If you've got 1 over 11th and we're dividing by p, when you're dividing fractions, that's the same as 1 over 11th times, turn the second one upside down. So when we're rewriting these constants as fractions back into our partial fractions, then the 1 and 11 can just join in with the denominator on the bottom. So it's going to be 1 over 11p plus 2 over 11 into 11 minus 2p. So there's our partial fractions. Now in part B, we're being asked about this differential equation. So we've got dp by dt is equal to 1 over 22 11 minus 2p. Now the dp by dt is a differential equation. It's telling us the rate at which the population is changing, but the dp by dt, it's not a fraction, but it can operate as long as we separate the variables and integrate. So because we've got these 11s in our denominators with our a's and b's, I'm going to take the 22 up and all of that down. I've missed a p out there, haven't it? All of that down and just leave the 1 on the right. So I'm going to integrate 22 over p and 11 minus 2p dp is equal to 1 dt. Now we can substitute in that our partial fractions were the equivalent to the 1 over p into 11 minus 2p, so we've still got our 22 there, and we can use our partial fractions, so it's just going to be 22 over 11p plus 22 times 2 over 11 minus 2p dp is equal to the integral of 1 dt. No, it's tempting to integrate there, but I tend to integrate all in one go on both sides so that you know that you have actually done it. But these 22s will cancel first, so we'll just be left with 2 there, and the 11, 22 will be left 2 there, and that 2 will times by the 4. So we've got the integral of 2 over p plus the integral of 4 over 11 minus 2p is equal to 1 dt. And now let's integrate. So this is going to be 2 the ln of p plus now the 4 can join in. We'll have the ln of 11 minus 2p. Now thinking about differentiating that will be 1 over 11 minus 2p, but then it will times by the minus 2, the differential of the denominator. So that should be a plus to begin with. So if we need to compensate for that, so that will change the front to a minus 2. And then on the right, we'll just have a t and then our constant of integration, which we just lump in on one side. Now we're being told that there are 1,000 meerkats in the population when the study began. So the population is being measured in thousands. So this is telling us when p is equal to 1 at t is equal to 0. And this information is going to allow us to find this constant of integration c. So when p is 1, we've got 2 the ln of 1, which is 0, minus 2 the ln of 11 minus 2, which will be 9, is equal to 0 plus c. So c is equal to minus 2 the ln of 9. So our equation is 2 the ln of p minus 2 the ln of 11 minus 2p is equal to t minus 2 the ln of 9. Now that's our equation, and we're going to use that to determine the time taken for the population to double. So when it doubles, p is equal to 2. So we can just say 2 the ln of 2 minus 2 the ln. Now when p is 2, we'll have 11 minus 4, so that will be 7, is equal to t minus 2 the ln of 9. And if you solve all that, take the minus 2 ln of 9 to the other side, you will get that t is equal to 1.89 years. So in part C, we're being asked to express p in terms of these constants and then this e to the minus half t on the bottom here. And so far we found that 2 the ln of p minus 2 the ln of 11 minus 2p equals t minus 2 the ln of 9, and we can see that we've got to make p the subject. So we take all the ln's to one side, and they've all got a 2 on the front. So if we take 2 out, we will have the ln of p minus the ln of 11 minus 2p, and then plus the ln of 9 when that comes on the other side is equal to t. And then using our log laws, we'll have 2 the ln of 9p, because they're adding, so that's going to be multiplied over 11 minus 2p is equal to t. And then just divide through by 2, we'll have the ln of 9p over 11 minus 2p is equal to t over 2. Why have I written t over t? T over 2. And then if we raised to the power of e on both sides, we'll have 9p over 11 minus 2p is equal to e to the t over 2. And now we just need to make the p the subject, and you can see that p appears twice. So let's cross multiply and take that 11 minus 2p to the other side. So e to the t over 2, 11 minus 2p. And we need to get all the p's on one side, so I'm going to multiply out that bracket. 9p is equal to 11 e to the t over 2 minus 2p e to the t over 2. Take that to the other side, so we'll have 9p plus 2p e to the t over 2 is equal to 11 e to the t over 2. Take the p out as a common factor. 9 plus 2 e to the t over 2 is equal to 11 e to the t over 2, and then just cross multiply to get p on its own. It's going to be 11 e to the t over 2 divided by 9 plus 2 e to the t over 2. Now quite often when you're dealing with this sort of equation, you want to think about when the population gets large, and with this t over 2, as t gets big, then e to the t over 2 is going to get big. So we don't really want to think about that and how we're going to get this to the minus a half. What you're going to do is divide throughout by e to the t over 2, so top and bottom, so each of these terms, so the numerator and both terms in the denominator. So divide everything by e to the t over 2. You're doing the same to the top and the bottom, so you're keeping the value of the fraction the same, but p will be, if you can see, 11 e to the t over 2 divided by e to the t over 2 over 9 divided by e to the t over 2 plus 2e t over 2 e t over 2. You can see that these are going to cancel here, and we'll have, because the e to the t over 2 is on the bottom, then we can put this on the top as a minus. So p will equal 11 over 9 e to the minus t over 2 plus 2. So we found that our a is equal to 11, our b is the constant, which is here the 2, and c is equal to 9. This next question is a modulus functions question. We've got two functions f and g. We're being asked to sketch them, and we're told that k is bigger than 1 and k is in both of the functions. So let's do f of x first. Now, if we just draw ln of x, should know that ln of x is this sort of shape, and it goes through here. The ln of 1 is equal to 0, and we've actually got the ln of x plus k. So we're doing transformations of graphs. We're adding k to the x before we draw the graph, and this is going to have the effect of shifting it minus k to the left. So we have to bear in mind that the ln of x graph doesn't touch this y-axis. The y-axis is an asymptote, so we're going to move the whole graph k to the left. So we're going to move the asymptote, and that will be x is equal to minus k. Now this place here, if you think of k being 3, then we'd be going 1 minus 3. So the place here where it crosses is just going to be 1 minus k. So that's that's the graph for f, and let's do g then. G is a modulus graph, and let's just think of say k was 3, 2x minus 3, it would come down, and obviously it would be going through, because k is positive, then it would have y-intercept minus k down there, but because it's modulus, we're going to reflect it up. This side will be 2x minus k, and this side will be minus 2x plus k, so the y-intercept there is k. Now what's this bit here, because we need to label where that crosses the axes, it's when 2x minus k is equal to 0, so 2x is equal to k, x is equal to k over 2, so that's k over 2. So that's part A for your 5 marks. Part B, write down the range of f. Now whenever it says write down, there's only going to be 1 mark, and you can just write it down. So when we're looking at the range, we're looking up and down the y-axis and seeing where this graph exists. Now even though it slopes over, it does keep increasing and extending, and the same going down the way. So if we look all along the y-axis and look out, we can see the graph. So the range for f of x is that it belongs to all the reals from minus infinity to infinity. So it just exists for all values up and down the y-axis. Part C, fg of k over 4. This is a composite function. We've got to apply g first. Now k over 4 is going in, and in our g of x graph, we can see that k over 2 is the x-axis intercept, so k over 4, because k is positive, is going to be less, so it's going to be going up, and we want the answer here. So we can just feed the k over 4 into this side of the equation, so that's going to be g of k over 4 is equal to minus 2 times k over 4, substituting it in as x, plus k, so that's minus half k plus k, which will be k over 2, half k, and then we'll do the next one. So you do g first and then f. F of the answer from when we've put k over 4 into g is k over 2, so f of k over 2 is just the ln of k over 2 plus k. So that will be the ln of 3k over 2, 1.5 k. Now part D, the curve C has equation f of x. So this is our f of x, this is C. The tangent to C at the point with x coordinate 3 is parallel to this line here. So we're talking parallel, and this is just a straight line. We'll need to get y on its own to get the gradient, and we're talking about things being parallel. So we can see that the gradient of the line is 2/9. Now where will the equation, the curve C, have gradient 2/9? Well, what we need to do is C is equal to f of x, and f of x is equal to the ln of x plus k. We need to do the gradient and equate that to the same gradient when x is 3. So we need to differentiate our f of x, which is just going to be 1 over x plus k, and this is equal to 2/9 when x is equal to 3. So that's what it's telling us there. So all we do is go 1 over 3 plus k is equal to 2/9, cross multiply. 9 is equal to 6 plus 2k, so 3 is equal to 2k, k is equal to 3 over 2. Thanks so much for watching. If you're still with me at the end of the video, good luck with all your exams and good luck with your revision. Do like and subscribe and check out my other videos, and I will see you on the next one.